In this video, I'm going to go through some of the steps that's necessary for simplifying the quadratic formula. Actually, solving a quadratic equation using the quadratic formula is pretty fast. It's simplifying your solutions that often takes the work. Again, the idea is that we're going to write a second-degree polynomial equation in the form ax squared plus bx plus c. We'll then identify the values of a, b, and c and substitute them in the appropriate place in the quadratic formula. Step 3, where you simplify your solutions, is what this video is about. So let's start at the end of the process. You'll have what people call a plus-minus symbol. And the idea here is that you're going to have two solutions, one where you add and one where you subtract. So you want to actually write both solutions. That is, one is going to be 2 plus 6 and the other 2 minus 6, and then you simplify and get your two solutions. Try this one. In this case, after simplifying both solutions, I get values of -3 and -5. And here's one more just to practice with some negatives and subtractions. After separating our solutions, here's the final result. Next, this term will often be a square root. In a case like this, where we have a nice perfect square like 25, we have to simplify the root first because of order of operations. The line 1 operators are always first. But notice now we're back into the type of problem we just did, where we're going to have two solutions, one where we add, one where we subtract, and you need to simplify. So here's one for you. Square root of 16 is 4, and after we separate our two solutions, here's what we get. Now, this is an example of what often occurs. You'll get a root, but it's not one that's a perfect square. On the other hand, we know that the square root of 8 is square root of 4 times 2, which will be 2 roots of 2. And if you're not aware of what I'm talking about there, you need to go back and look at the video on simplifying roots. Now, once we've simplified square root of 8, we now go back to our idea from a minute ago. We're going to have two solutions, one where we add and one where we subtract. It's this simplifying step right here that takes a little practice. I would recommend that you make two fractions, each with the common denominator, and then it's easy to reduce to 1/2 and square root of 2 over 2 once the factors of 2 are reduced. So what we're doing is we're separating here so we can reduce. Because the mistake students will often make is they'll reduce this 2 and this 4 to 2, but they won't have this term affected by the 4. By separating like this, you have both terms affected by the denominator of 4, which gives you the correct answer. And why don't you try the other one? That is the one where you subtract. Once again, we'll make two fractions. 2 over 4 is 1/2, 2 over 4 is 1/2, and so this will be 1/2 minus square root of 2 over 2. Now, we often don't separate these into two. What we do instead is, once we say, for instance, square root of 18 is 9 and 2, so that'll be 3 roots of 2, we just separate and keep this addition and subtraction to remind us we have two solutions. So one solution will be 2 plus root 2, the other will be 2 minus root 2. People often leave it like this, but if you want to separate them, that's fine too. Here's one for you. Please pause the video and try it. First, we have to simplify root 75. Of course, that's root 25 and 3, so we get 5 roots of 3. Next, we have to make two fractions, and after reducing, here's our answer. Again, if you'd like to write this as two different answers, that's fine also. Now, here's an example of the entire process, so please pause the video and try to simplify this one. Well, we'll have to start in the radicand, and this will be 49. This is the most problematic piece right here. You'll need to decide whether you're going to hold it as a subtraction or change this to adding a -4 as a factor. I hold it as a subtraction, and I just find this product and I subtract last. So the way I do this radicand is power first, product next, subtract last. Of course, opposite of -7 is 7, and 2 times 1 is 2. And now 49 minus 40 is going to be 9. Square root of 9 is 3. We go back to the ideas from a minute ago and find that our two solutions are 5 and 2. Try this one. Again, I have to start by simplifying the radicand. Power is first, that will be 121. Product is second, that's 40. And then I'll subtract. This will just be 11. This, of course, will be 4. 121 minus 40 turns out to be 81. Root 81 is 9. And then again, we have our two solutions, which we simplify. Try this one. After simplifying the radicand to 0, and remembering that square root of 0 is 0, it turns out we have two answers, one where we're adding 0, one where we're subtracting 0, but of course that's the exact same value, so usually we only write one answer, even though it showed up twice. And here's the last one. In the radicand, I'll get 4, and then I'll be subtracting a -8. Of course, this is 4 plus 8, which is 12. Square root of 12 is root 4 times 3, so that'll be 2 roots of 3. I now rewrite as two fractions so that my reducing goes correctly. And here's my final answer. Again, if you'd like to write this as two different answers, that's fine also. Well, that concludes this video where we went through some of the skills we'll need to simplify using the quadratic formula. In the next video, we'll actually work some problems from beginning to end with quadratic equations.